Hey everyone, welcome to the Hasura Wednesday live streams. Happy to be back. And today is my favorite topic. I'm going to talk about authorization with Hasura. And yeah, so before we dive into this, do let me know in the comments if you have any specific questions around authorization and anything around role-based permission system, any quirks you have faced while building apps. But I'll be going over some examples and we can go over some real-world examples with um, with Hasura. So in today's topic, we're going to cover what role-based access control system looks like in Hasura, then the dynamic session variables that are being used, and custom claims via JWT or the ones that are returned from webhooks. Then in roles, we look at hierarchical or flat. So we divide roles into different categories. This is not a definitive list, but this is what something that I personally use for categorizing what kind of roles will typically fit in. This could be hierarchical or flat, administrative or not administrative, depending on what task a particular user can do in an application and whether the user is logged in or not logged in. So restrict data access based on those two conditions, right? And finally, we look at what is the case for multiple roles. There are cases where one role is more than enough, but there are also other cases where your mental model looks around for different roles and permissions for each role separately. So in today's example, we have uh, Google Docs, which is like a real world live collaborative document editor with access to different permission system. We have users, we have editors, and we have owners who can access documents, and few people can edit, few people can just view. We'll see how that can be translated into our authorization system. Then we have an organization, a simple employee manager role split. Then we have an employee payroll system, and you have a university department with departments that are different departments, and then different students will be able to access information from the department that they belong to. Finally, we'll also look at Slack clone, the one that we have on our Learn course, which is talking about how to set up permissions for a Slack kind of an app, which will have different models like workspace, channels, and messaging. So that will be an interesting use case as well. Um, and finally, in our security aspect, apart from the role-based access control system, we look at unauthenticated public access, which is to say whether you're not logged in, then what do you do? And adding allow list in production. And we'll talk about the roadmap to come in with remote schema permissions and action permissions, right? Cool. So now we'll start off with the first example, in fact. And before we do that, just going to look at some comments. There are a couple of greetings, Chan and Joel. Hello, folks. Do let me know where you're coming from. So I am from Bangalore, India. Which part of the world you folks are coming in? Please do drop in the comments. I know it's probably pretty late around Australia, probably sleeping. Then there's US, which is probably just morning times. Interesting to see where people are joining in from. And there's a question. Can you talk about Keycloak implementation? And regarding external auth providers, where to store user profile information inside Hasura or in the auth provider? Great. That's a pretty good question from Jan. So the idea behind auth information, the user information, is that typically your user information is stored in an external auth provider as a basic information, which is to say the user ID and some kind of metadata about the user, which will be part of your external vendor. For example, in our typical docs examples, we use Auth0 and Firebase, where the information about the user's ID is stored in Auth0. But any other information regarding probably like the profile picture or email address and any other metadata that could be relevant to the user, we typically try to store that in the user table in Postgres. And and the choice between storing what fields to stay in Postgres and what fields will be in your external auth provider is still up to you. But the primary information that's required in Postgres is the user ID, because you will use that information to filter and like create permission rules for all the tables. So storing the user ID in the user table in Postgres is going to be like a bare minimum that you'll require to store. And once you do that, the other metadata like the name, email address is probably irrelevant for the permission system, but just the user ID is pretty important for the permission system to work. Once you have the ID, you can set up permission using the session variables called Hasura user ID, and the roles will come in. We'll go over what roles and session variables are in this example. Cool. I see people joining in from Uganda, Germany, UT. Great. Awesome. Different regions. Great to know. Cool, folks. So going to my first example, which will cover Google Docs document analysis. Now, let me just moving over screens. Got it. So typically with Hasura, the idea is that you will create most likely one particular role and then start defining permissions for that. But the usual mental model around role-based permissions is that you start thinking about uh, multiple roles, literally. For example, in your organization, example, you will talk about employee as a role, as a manager as a role, and there could be different hierarchy set. And depending on the hierarchy, you will actually define them as separate roles. That can become pretty lengthy in terms of the number of roles you will maintain. So we'll think about a different way of approaching this problem with the Hasura's permission system. We have a single role through which you can apply some permission operations, like limiting the access to the rows and the columns, which will actually let you figure out the data access layer permission and avoid defining multiple roles unless it's a very specific use case. So starting off with Google Docs example, I have this cloud project with a few schemas, and the public schema has the Google Doc schema. I will actually try to see how. So this is the schema. If you folks can see, I can probably even zoom in. Yeah, I think this is pretty much zoomed in. Cool. So we have users, obviously with an ID column. I've removed the other metadata columns about the user. But the idea is that for a Google Doc kind of a use case, we have users and we have documents. And between these two, we have different roles called the owners, editors, and viewers. Owners can obviously, they were the ones who created a document. And for editors, some permissions were allowed by the owner of the document to add editors to a document so that they'll be able to edit documents. And viewers are somebody who just has read access to the document. So, so in a typical scenario, we will think about having three different roles here, which is to say owners is a role, editors is a role, and viewers is a role. But in Hasura's use case, when you are defining a role-based permission system, think of these different tables as just different data sets, and you will be able to like traverse through different relationships. Since owners, editors, and viewers are linked to the user table, and they're also like linked to the document table, you have some sort of a relationship between all of these tables, which means that when you're setting up a permission, you will be able to traverse through a different permission, different relationship. So if I'm trying to access a particular document, I should be able to um, I should be able to access it only if I'm an owner or an editor or a viewer. But if I'm trying to modify something in the document, I should be at least an editor or an owner. And if I'm trying to delete a document, I should definitely be the owner and not anything else. And inserting a document is basically like anybody who's logged in can insert a document into the table, which is like creating a new document in Google Docs, and then you can actually create a row, right? So to understand this in the context of having one particular role called user, maybe you can call it whatever, but that is one role. Let's assume it's user. They'll be able to define permissions by combining data from by traversing to multiple tables. They'll be able to define a permission, right? Instead of declaring uh, three different roles and then defining permission system for each role separately. Because after a point of time, if you're defining multiple roles, it probably doesn't scale because you might have a different hierarchy going forward. Like Google Docs is probably not the right example for a multiple role use case, but let's say you have an employee organization hierarchy. You have employees and managers and team leads and the CEO and so on. So in that kind of a use case, the hierarchy keeps probably increasing, and you can probably bring in more and more granular hierarchy. In that case, this creating new roles for each and every hierarchy will probably not work well. So the idea to think about is it in the way of traversing through relationships with the existing data set and then try to access them and then set up some permission system, right? And cool. So now that we have the schema ready, I have the users table, I have the editors, owners, and viewers as separate tables. The idea is that we need to define permission to access documents for a particular role. Let's say the role is user. Now, to access a document, I need to obviously define a select permission with some custom checks. Now here, I should be able to do it only if I'm part of either an owner. So if I'm an owner, I should be able to select data. This would be owner user ID and user ID equals to X Hasura user ID. So now we look at what this value means. This is something called as a session variable. This comes in from the authentication server that returned probably a JWT or from a webhook which returned this value. So going back to a JSON web token, I have a sample JSON web token defined. This is a token that I generated by logging into my existing cloud project. So this has given me a payload, and the interesting bit is this part, which is Hasura specific. Rest of the payload is just typical data for your JSON token. This is the payload. This is the key that we are concerned about. This key has information about the Hasura role, the Hasura user ID, and so on. What this means is that this value is being dynamically configured every time an authentication request is being made to the authentication server. So let's say I'm trying to sign in to my auth server. There is a JWT token that is getting generated when the authentication is finalized. During the generation process of this token, I am setting these claims uh, as part of the payload of the token. And I'm setting in a default role, and I'm setting in an allowed role list, and also the user ID data. The reason why it's prefixed as Hasura is so that Hasura server can understand that these are the session variables that are coming in from the token. And hence, these values, the values that are present here, they can be substituted in the permission system. So if I go back to my permission, now if I use Hasura user ID over here, I can just probably zoom in a little bit. If I use Hasura user ID over here, this is basically saying the value has to equal to a value that was present in the JWT token, the claims payload, right? So, so the OR condition is to say that to access a document, I need to be either an owner or I need to be either an editor, which will also be a similar condition where the value would be accessed by user ID. Or finally, I can just even be a viewer. A viewer will also be able to access a document. Cool. So this condition, now with this condition, we have defined an OR operator, which means that either one of these three conditions need to satisfy. And if I'm an owner, I should be able to access this. If I'm the editor of the document, I should be able to access it. And if I'm a viewer, I should be able to access. So there are no specific different conditions for this. So we are just declaring an OR operator and then defining three different conditions to match. As long as in either of these matches, I should be able to access the document. So if I'm a user and if I am part of either of these three tables for this particular document ID, I should be able to access the document irrespective of the permission, because the permission allows me to access for all three roles, like owners, editors, and viewers, right? And I'll give access to ID column, which is fine. So this is the column-based permission. Now, once the select permission is done, we'll go to insert. Anything to do with modifications will have a slightly different impact. With insert, basically anybody can insert a document. And with custom check, what we'll do is we'll just want to ensure that they are able to insert only as a user and not as anybody else. So we'll do a column preset for a document to say that, okay, this is the user that is supposed to insert. Now with update permission and delete, it's slightly more specific. With update, an update permission can be applied only by owners or editors of the document and not viewers. Just read access to this document, those users will not be able to update. So we need a condition to say both owners and editors can edit this document, can have permission to edit this document. So the same condition check, the OR operator, but this time around, I'm just going to have two conditions, which would say the owner's user ID has to be equal to Hasura user ID, which will come in from my JWT claim or from my webbook. And for the editors, the same process, which would be editor's user ID has to equal to the Hasura user ID. We are basically not allowing access for the viewers relationship to be viewers user ID to be accessible for this. And so this will prevent updates for viewers. This will have permission just for, if you're an owner or an editor of a Google Doc, you will be able to make edits. So ID column, obviously for the column permissions. So that should work. And delete becomes even more granular, where it's a simple single condition where you're saying you have to be an owner to be able to delete a document. So there is no or operator, there is only one condition. So you directly traverse through a relationship. Here you say owners is the relationship and their user ID value has to be equal to the accessor user ID value. Cool. So I'm going to save permission. There's no column to select for delete. Delete happens. It just happens, right? So I delete. I have configured permissions for delete, and the only thing that we've done differently rather than um, declaring multiple roles is that, so I could have probably done something like owners having a role and maybe like defining some sort of a permission, let's say. And I could also like define two more roles for editors and viewers. But that wouldn't really scale well for this use case, and we don't really need to do that because the information that is required to filter data for authorizing this data is already available through relationships. So as a if I'm accessing document, I should be able to access it as long as I'm part of this document. And the same case with update and delete, where there is a set condition that deletes or updates can happen only through owners and with permissions for editors, right? So once you're able to traverse through relationships, in most cases you will be able to define permissions with just a single role across your application. And that's how you should probably do your modeling of permissions with Hasura, rather than straight away declaring multiple roles. Right. So just looking back at the comments for more questions. All right, everything seems fine. Cool. Now we are done with the Google Doc example for defining document level access permission. We've just used or operator and then did a filter for all of these insert and update and delete operations. Select was just slightly more free. For anybody who's logged in, they'll be able to select, and as long as they have permission uh, for doing it through these three checks, right? So this is all about the Google document uh, per access role. So the next example would be the organization employee manager use case. This will be a hierarchical use case. Here, what the data model is simple. I think this is probably the payroll one. All right, we can go over the tables over here. So we have users, we have roles. So the role table has information about what the role information is, and we have a mapping of users and roles in an intermediary table. So we have this many-to-many relationship, and we have a documents table again. So consider an example where you have an organization with uh, a hierarchy of users. each having a role, let's say a manager or a team lead or something, and they will be able to access documents based on a particular role capacity. The role is basically the manager or an employee or just uh, a beginner, junior, whatever, right? Now, based on this role information, we have to restrict access to documents to be accessed. So, so the use case here is that there's no information that is linked between a document and a role. So if you look at the document table, there's only an ID, and these are like raw generic information for the document table. Obviously, users and roles are mapped together. So there are users and there are users and roles are mapped in this table. What we want to do is to access a document, we should set up a permission which will uh, traverse through tables to find out some information about what role they are, the user who's trying to access, what role do they belong to before allowing access to the document table. We have this view called flattened user roles. If you look at the view information, we're just using the recursive Postgres statement, and then we're just flattening out all combinations of roles over here. And what this does is, if we have defined user roles over here, where you have mapped user ID and role ID, obviously one user can have multiple roles, probably. So all of them are employees, for example, and then some of the employees are probably managers as well, and so on. So there can be multiple roles assigned for each user, and that information is captured in this table, user underscore roles. This flattening of tables is to ensure that you're able to traverse through an intermediary relationship so that it captures all combinations of role information for users. Now, our goal is to access documents table, and the permission system for that. I'm going to ignore the owner's role, which we defined in the previous example. So for the user role, for accessing documents, we have to set up a condition. Now, for this to work, I need to be able to access information in a different table, which is not related to the documents table. If I open the operators and the columns, I see that there is no relationship from document table to any other table. Documents are just generic set of documents which have no relation to the user or the role. They're just generic information, generic documents, files which can be accessed. But the access rule is that you need to be probably a manager to be able to at least access this. That is the only condition. Now, for accessing a document, if you need to be a manager, then you have to establish some sort of a relationship between these two. And that is not possible directly with the relationship data because you don't have a relationship between documents and user roles, right? To overcome that, what we have is like an operator called exists. Now, what this does is it lets you traverse through relationships to different tables, and then filter out data based on this particular condition. So there is a documents table, and you have some unrelated table technically because there is no relationship between documents and roles in the schema structure. But you want to filter out the data fetching of documents based on a particular role. To do that, the exist operator will come in place where now you can use this operator to access information on a different table where you don't even have any kind of a relationship between the tables. So from documents table, I'm doing an exist operator. I'm just doing a check for the flattened user roles. And then I'm going to create a condition which says I need my user ID has to be equals to X Hasura user ID. So this would probably even be an AND operator. I have to match a couple of conditions. My user ID has to be equal to the session variable X Hasura user ID. And then the role ID will have to be equal to, let's say, a manager. So this is what we can do with exist operator. You can see that there is no relationship between a document table and the role table or the user table. But what we've done effectively is we have traversed through different tables through this operator called underscore exists. And because of that, we were able to filter out data for documents based on information of these two filters. The filters are basically just saying filter user ID for the session variable Xasura user ID, and the role has to equal to manager. This could be any value. This could be a bunch of values as well. I could do an in as an array of roles. So as long as a user belongs to one of these roles, they will be able to access data, right? So this flexibility to write a permission for accessing data from a different table, which is unrelated, is 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 a pretty cool feature, and this is possible through underscore exists operator. So this, if you have to model this permission on your own when there is no relevance between the other tables, then you will have to probably write a traversal for fetching that information and then doing some sort of filtering before returning it back to the client. With Hasura, what happens is that obviously when you do a row level permission, this is done at the compiler level where the SQL statement that is getting generated before it goes to Postgres will have these conditions in the where clause, and you will only get the right information back from Postgres, and there is no filtering of data. So the performance is obviously going to be very fast rather than the other approach where you do manual fetching and then change some and transform some data. Cool. So this wraps up our second example, I guess, the employee manager, the hierarchical role. You have a hierarchy of roles, but you are still able to restrict permissions based on just one role. We have this one role called user. So even here, we didn't have roles like manager or owner or team lead, etc. Right? We were able to get away with just one particular role, and then we define permissions which traversed across different tables. Awesome. So just going back to questions, Jan asks, could we also have the user tables in a separate PG database or container? Got it. So the user table has to be in the same database as Hasura is, because from the example that I showed you, like for example, the documents, probably not the document. I'll go to the public Google Doc example. If I go to the user role, if you look at the condition over here, the owner table is traversing to a user ID column. The user ID is being checked for a session variable like such as user ID. Now, if the user ID is not present in this database table or columns, then you won't be able to do this condition, right? In that case, the permission system will not work as expected. So the user ID has to be stored in the Postgres database where you're actually making the query, where you're actually defining the filters and permissions. And if it's on a different database, then it's not going to be available for you to access it in the permission system. But what you can do is you can probably define it in a different schema, in which case you can establish relationships between them and then probably try to apply permissions. Cool. So that's answering Jan's question. There's another question from Sujay. How to implement the authentication system where users have option to choose from multiple roles like here? Is it possible with Auth0? Yeah, so with Auth0, when you're defining the JWT custom claims in rules, you can actually, so the, just going back to this example of JWT token, the payload that you see here, this is generated during the login or sign up process whenever the authentication service renders this rule to generate the token. So this is pre-generating the token. This code can be changed. This claims being generated can be manipulated, and you will have context of the user information from Auth0 on what the current user's ID and role looks like. And based on that, you can assign a different information in this payload. In fact, you can even make HTTP API calls to the database and then fetch some information. And then based on that output, you can do all sorts of custom business logic before assigning information like user over here or even the ID over here and so on. So this is one rule that you can execute with some custom logic before generating this payload with custom claims. The other rule is that once you have done this, the second rule is to insert this user ID data into Postgres, where so that it's like a syncing of data from Auth0 back to your Postgres data. You have a users table in your Postgres database, and you want this user ID from Auth0 to come back into your database so that you can do some session variable checks in your permission system. So that is another rule that you can execute. So there are rules in Auth0 which you can trigger and modify data and transform data. Um, I hope that answers the question. There's another question from Jan. Could we use Hasura actions for permission checks? So currently, there is permissions for actions, but it's slightly limited in the sense of you can. I'm just going to quickly create this without modifying anything to just showcase what the permission system looks like. Yeah, so we have this action getting created. We have this permissions. Now here, you can only say that this user is allowed to perform this action, and currently you don't have a way to granularly specify whether I'm able to access this particular column, this particular field. Let's say access token. Let's say there are multiple fields, and you cannot currently granularly specify which field you can access as a particular role. That is being worked on, and this is also applicable for remote schema permissions. Right now, you don't have permissions for remote schemas, but we have like a preview available on the OSS repo, which incidentally also we are demoing tomorrow in the community call. So that can also be looked at. But to answer your question, yes, we are going to add granular permissions for both remote schemas and actions, and then you will be able to add your own resolver, your own custom logic, but then use Hasura's authorization layer to define permissions. Oops. So yeah, I mean, can we utilize actions for permission? Mm, not sure if I understood it wrongly. So, do you mean that in probably like an exists operator or something, you want to traverse to an action uh, relationship? Is that what you mean? Or if you mean that if I add a relationship from an action to a table, then the permission for the table will still remain the same. So even if I try to access the relationship data from an action, if as a user, if I'm logged in and if I'm passing in some token, and my underlying table in this relationship doesn't give me access, then I'll still not be able to access that data. So that permission still applies. But if you are looking at the other way around, where you are in your permissions for documents, and let's say you wanted to check a condition through an action type, then that is not possible because currently you will not be able to establish a relationship between a table and an action. The other way around is possible, where you are defining a relationship between an action and a table. So, so once you have this feature ready, where you can define a relationship between a table and an action, then you will be able to definitely add permissions. Currently, you have remote schema relationships where you can add a relationship between a table and a remote schema type, but actions is something that is still not available right now. And I think with tomorrow's preview of remote schema permissions, actions will be the ones that will be worked on next, and that should give us a fair idea. Cool. Awesome, good questions. And we can move on to the next example. Meanwhile, this is the employee payroll system. Probably slightly boring example, but this is the example which will let you define multiple roles. So far we've looked at defining one particular role called user, and then getting away with defining all CRUD operation permissions for different kind of use cases. But here in a payroll system, you have different permissions for different kind of roles. So this you will have to probably declare multiple roles over here, and I'm assuming this will be one example would be there is a role called HR, there is a role called employee, and there is a role called manager. The HR will be able to like select or do any CRUD operations without any conditional checks. Consider them as like the admin of that role. Then there is an employee who's able to access their own payroll and do nothing else. There is no mutation that is possible for an employee. And for a manager, you can select anybody's payroll, but you won't be able to modify anybody's payroll. So you're just slightly senior to what an employee can do. Manager can just view every employee that a manager can see. So that is the only change with between a manager and an employee in the select permission. The mutation, which is insert, update, delete, they're all restricted for both employees and managers. So this is a case where we'll have to look at a multi-role permissions. So going to this payroll, I already have owners and user. I'm going to create this HR role and with some checks. So the HR role actually doesn't need any checks because they are kind of like an admin person who can access every employee's data. But the only check that you might want to do is to see if they're logged in at some point, and that can be done if you have user information stored in. Um, So maybe if you have a users table and then you have an ID column, which is mapped to the accessor user ID value, then you can just check if they're at least logged in before accessing this. But in any case, rest assured that only if a JWT token, uh, the token that returns a HR role will be able to access this. And your backend server will not generate a JWT claim with HR role unless they thought that this is the authenticated HR user, right? So you can have no checks for these for the HR role. So same for all CRUD operations for HR role. Insert, update, delete will be no checks for HR. Now going to employee, they won't be able to do any CRUD operation in the sense of they won't be able to do create, update, and delete. They can do read, and there will be a check for the employee as well. The employee's ID needs to match the logged in's user ID. So employee ID has to equal to X as a user ID. So this condition will ensure that an employee will be able to access only their own payroll, their own data, and not anybody else's, which is slightly obvious. Now I can give permissions for the columns. Finally, for a manager, there is a select permission. Again, here manager cannot modify any data, but they'll be able to read any data. And for a manager, they will be able to select without any checks because they are kind of slightly lower to HR in the write scenario, but the read scenario is equivalent to what a HR can do by reading up any employee's payroll. So I'm going to do a without any check condition, and that will just solve our permission system for a payroll use case. So for HR to complete this, we'll have to allow access for insert, update, and delete without any checks. Employee will have a restricted check. Only they can access their own payroll. Managers have a non-restricted check for select, and they won't be able to do any kind of modifications to the tables, and hence this will close the loop for this multi-role system. Now, if you have to imagine doing it in a single role called user, you won't be able to granularly specify whether you're a HR person or you're an employee or you're a manager. For that to happen, what you can probably do in your database is that you can probably create a table called roles and then define the HR or a manager or an employee role information and then tag it to each employee. So this will again now go to the hierarchical role architecture where you will flatten out the roles and then come back to doing a single role based permission. Here, instead of flattening out the roles, we are creating multiple roles called employee, HR, and manager, and then declaring permissions, right? Now, when you're logging in with, let's say, Auth0 or any authentication provider, when you're generating the JWT token, what you have to keep in mind is the employee. If an employee is logging in, you need to put the role correctly. You need to put the accessor role value to be employee or the right value like HR or manager, whichever comes in, depending on who's logged in. So you need to have this information in the database to be able to assign the right role to the JWT claim when it's getting generated during the authentication step. Once that is generated, it's just a matter of Hasura applying that permission from based on what role was given, right? Going back to our example, we have a university department example, I guess. Um, just going to see which schema is that. We have an attribute schema. Cool. So we have users in, let's say, an university, probably students, and you have like a bunch of documents which belong to a department. There are obviously departments in a university, and then you have users in a particular department, and you have documents which belong to a department. Kind of a simple three-table data model. Now, the use case is that I should be able to access a document if I belong to a particular department. I should be able to access documents of a department as long as I belong to that department, right? This mapping is already there. The mapping of users and department is already there through this relationship. Every user table row will have an ID and the department that they belong to. Now, with this combination, we have a relationship called department through which you can traverse through and back. And so this is an object relationship, and the other way would be in a relationship where you come back to documents and users as an array relationship, right? Cool. So now to access a document, I need to be able to access it through, let's say, a role called user with custom check, obviously. I should be part of a department, and my user ID has to belong to X Hasura user ID, right? So what this condition is doing is to access a document as a user, I'm just checking if that user belongs to the same department of the document. And that's it. And that's the only select condition that I need to worry about. This is basically going towards an attribute based uh, authorization where we started off with a relationship called department, and then we are traversing it through users and then checking the user's ID. If you look at the documents table, the documents obviously do not have a user ID directly linked to it, but the link between the user and the department is there, is established in the users table, right? Now, with this information, we'll have to establish a traversal of relationship to establish a permission, and that's what we've done here without any checks. Sorry, with the custom check, which will have a department relationship, and which will go to users, and the user ID will be equal to the Xasura user ID. And the permissions for columns will be the same. I can give access to both the columns. So this is an attribute based example. Again, single role. We don't have multiple roles use case for this. This is a single role called user, which has access to um, department files like documents based on which department I belong to. Now, there could be documents from other departments which you shouldn't be able to access, and this permission will take care of that. But what if you want generic access to all the documents? Then your permission is basically just to say, as long as I'm logged in as a user of the organization or the university, I should be able to access this, right? Then your condition will be user ID equals to accessor user ID, and that's it. You don't need to belong to a department as such specifically. Cool. So just going to save this permission to wrap this up. Cool. Checking back for comments. We don't have any new questions. Cool. Now, coming to our last example, which is the Slack clone. The Slack clone is something that we've done in the Hasura Learn series. I'm just going to post this link on both the chat and on the banner, on chat. And so this is the Hasura Auth Slack course. Mm, I'm going to show the data model for Slack. It's slightly complicated. Um, we have users and we have, if you're familiar with Slack or any chat application like Discord or something, you typically have like a workspace, like an organization, and you have users, you have channels which belong to that workspace, and you have members in each channel. And finally, the aspect is around the messaging of the messaging and the threads that gets created. So that's roughly the data model. Um, it might look pretty big in terms of the number of arrows going around, but you have workspaces, you have channels, and you have like users obviously will be there, and you have the messaging aspect where you have threads and messages for threads. So that's fundamentally what the Slack data model looks like. Now, for a Slack kind of a clone, the the way you will actually look at permissions, you have as a workspace admin, you should be able to access any channels and obviously create channels as well, create, modify, basically have full access to channels. And there are cases where the only case where a workspace admin won't have read access or write access is the private chat between two different users. So the user message table, which has a user ID and the recipient ID, if this is a private user message, then the workspace admin, the workspace member who's of type admin, shouldn't be able to access this user message table, right? That is the only caveat for being a workspace admin, but in terms of the permission system. But otherwise, you have, as an admin, you have unlimited access for creating, like doing all the CRUD operations for channels which are public, and you'll be having read access to to getting the list of channels if even if it's a private channel, right? And for threads, obviously, you will have CRUD permissions for managing threads on the channel because it's public. Again, the private channel threads, that's something that the workspace admin won't be able to delete um, as long as the permission system is configured in that way. So if you go to thinking in roles section, again, we'll go back to the initial classification of roles where you have hierarchical and flat or administrative and non-administrative. Your permission will lie into any of these two categories. I have a third one, which is based on whether you're logged in or you're not logged in, right? And the case for multiple roles is basically when you're logged in or if it's a publicly accessible data. If it's a publicly accessible data, then you need to define something called Hasura GraphQL unauthorized role, and then define permissions for that particular role, and then give access to either create or read or update based on that. And that will be different for a logged in user, because a logged in user will have different permissions, whereas some data is just publicly accessible or publicly insertable without any user identity involved. That case, we need a different role for that scenario. So there'll be multiple roles involved in that. And the other case where you need multiple roles is when you need access to different columns. So if you look at our example of the payroll system where we actually had multiple roles like HR and manager and whatever, the employee. we actually had different conditions required and access to probably like different columns as well. For example, if I'm an employee, like this has a pretty limited set of columns, but as an employee, there could be something called uh, internal remarks or something. Let's say I have internal remarks column, which is of type text. Now, let's assume that an employee has gotten some remarks added privately. So they won't be able to access their own um, remarks, in which case I will not allow access for the internal remarks column for the employee role. But the HR, on the other hand, will be able to access the internal remarks column, which means that the permission is different for HR and the permission is different for employee based on which columns they are allowed to access on the same table. And that's when the case for multiple roles will also kick in. And that will be something that you'll to keep in mind. So going back to the Slack example, so now different access to columns is when you have multiple roles, obviously, and then when you have admin support teams, like admin dashboards, which have granular access to data in your backend, and you have like support teams which can override all of these permission constraints and then do a trigger for like instant customer support or something. That's when you will probably have multiple roles which has privileged permissions in certain use cases. And for Slack clone, we are going to stick to only one role because everything can be expressed in terms of traversing through a relationship and traversing through different columns. So just like I'm just taking the workspace, users will have simple select permission. The users can access their own data and they'll be able to read any workspace members that they are also part of. That's a simple select permission. Obviously, user can't insert on anything. Uh, the update permission is to update their own user data. So that's pretty simple. Workspace is where it probably gets interesting, where you will have a permission like an OR operator being used, a Boolean expression. Uh, so who's able to read a workspace data? So either I should be the owner of the workspace or I should be part of the workspace membership, right? So those are the two conditions which you need to have to do a select. And insert is obviously if the owner ID is equal to the accessor user ID, you can insert and then have a preset as well configured. Update again can be done only by the owner. So the condition will be to check owner ID is equal to accessor user ID. And the column level update, you can say which columns you want to do, like the owner ID created at columns. Again, delete again will have permission only if you're an owner of the workspace and so on. Similarly, for channels, you can have read permissions for channels if you are part of the channel, and you can insert if you are an owner of a channel or a owner of a workspace. And again, same for permissions for delete and update. So if you look at this permission, which is the insert permission for channel, so who can create a channel? Uh, any workspace member can create a channel, and any workspace members who are either an owner or an admin can also create a channel. So this is just like a combination condition, and we're just making use of an and boolean expression for enforcing this, right? So I think this is broadly what the Slack clone permissions are. It's just going to use like one single role, and we're just traversing through relationships to achieve the use case for um, permissions. So the examples are done. I'll quickly look at the comments. Are these data model diagrams available online? There's a question to make us. Yes. In fact, I will just share links to all of these. We have this data models coming in from this particular blog post that we wrote earlier, which talks about authorization system through different examples. So I've posted the link on chat. You folks can check it. And for the Slack course, I think I've already posted another comment which will have the learn course link going through the Slack clone. So this is the Slack clone course. And finally, for the last bit, which is other security features like unauthenticated public access. For this to work, we'll have to go to the Cloud Console and then add an environment variable called unauthorized role. Let's say I call this role as public. So what we typically do with unauthorized role is that we define permissions for this role, and then we say that whenever there is no authorization token sent or an admin secret being sent, we assume that it's unauthorized. Hasura assumes that it's unauthorized, and then it takes up this role, this configured role as public, and it will start applying permissions that are declared for this role called public. So we can define a new role called public and then let access to based on some conditions or any or without any checks in most cases, and then probably to a limited set of columns for the public role. And we can say permissions. So when somebody makes a GraphQL query without any authorization token or admin secret, or they don't have webhooks configured, they will be assumed as an unauthorized role, and the unauthorized role is configured to be public. And this role's condition for the operation will be applied when a query is made. And the next thing is to use allow list in production. So to showcase that, in the Pro tab of your cloud project, we have something called allow list. You can start creating operations based on the queries that you make. So this will be totally dependent on how many queries we make through GraphQL interface or through your HTTP request from your front end or your backend. And they keep getting populated over in this allow list. Now, based on that operation list, we can actually select them and then add it to allow list. You will be very clear about which particular set of queries are being made for your application. And you can specifically only allow those queries to be authorized instead of allowing anybody to just try out a query through the introspection and so on. So you can add an allow list by selecting the different set of operations before going to production. That's like one way of ensuring authorization before going live in production. Cool. So finally, roadmap. What we've seen so far in the permissions examples were primarily for Postgres or for databases, if you can take it generically. But if you have added a remote schema through Hasura console, then which is a different GraphQL server, you currently cannot configure permissions granularly for that remote schema. And similarly, it applies for actions. If you have custom types with actions, you won't be able to apply permissions for that as well. So this is all coming up next. We have 1.4 coming up pretty soon, and we have a demo tomorrow in our community call, which will have a demo for remote schema permissions in with the console and the CLI. So this will be pretty cool to get started, and this will open up the whole authorization system to any generic GraphQL endpoint. You can add them and then add a role-based permission system through Hasura, and Hasura will behave as the as a central layer between your client and any other API data source and becomes the authorization layer, right? And that's why I think for me personally, authorization is a favorite feature because instant GraphQL APIs are cool. You get it out of the box, but um, that probably is something that I can write a few endpoints and then get away with a few resolvers with GraphQL. But authorization is something that I'll have to like write conditionally for every particular use case. And then my modeling of data and modeling of my code is slightly dependent on the authorization rules and the role-based permission system, right? So having this out of the box in a declarative way, the way that the console UI gives you, or the metadata that you can create through YAML files, it is just my favorite feature, to be honest. So that's mostly what I wanted to cover today. Jan asked the question, can we give user roles a timeout? So in our Pro tab, if you look at API limits, you can configure API limits to say, um, let's say 10 requests, or let's say 100 requests per minute can be made by access role, a unique role, and this will apply a limit of 100 requests per role per minute. So this kind of granular limiting can be done. Although this doesn't answer your question directly in terms of timing out, this actually limits the number of requests that can be made technically by a particular role, right? So hopefully that will help you out in the role timeout question. Awesome. So unless there are any more questions, I think we are probably running out of time. And then I think it's been a pretty good session covering out different examples for authorization. Once the remote schema permissions come in, that will be a cool stream to do. I am pretty excited to do a remote schema and another remote schema added, like having two, three remote schemas from different vendors being added and then adding a permission layer on top of that. And obviously combine it with permissions with your Postgres or your MySQL database. That would be pretty cool for demo and like pretty cool of a use case in real world as well. And GraphQL being a single source from your client. So hopefully that will be done pretty soon with 1.4 going out. That should be a good demo to showcase next time around. Awesome. So thanks for joining in, folks. That's it for today. Feel free to drop in any more comments and then we can take it asynchronously on Discord or YouTube. Feel free to subscribe to the channel. We have these streams every Wednesday, 9:30 PT, and we'll post up on Discord on what the next week's live stream is. If you have any preferences on what topics you want to cover next week, do post out in the comments and then we'll take a look at what are the community requirements and then we can do a stream around that. Cool. Awesome. Thanks for joining in, folks. Have a great day. Have a good night. See you until next time. Bye bye.